Question number 8 is actually almost identical to question number 7. It just doesn't look like it at first. So the good news is we're going to really start to establish a routine, a set of steps that's going to work in every single problem. We just need to make sure that every single problem looks the same, because that's the only way to really get a routine, is to make sure that we have the same setup, the same exact things to look at. And that's what makes number 8 at first look a little deceiving, because it doesn't look anything like number 7. Until we recognize, and hopefully this is getting a little bit more natural at this point, that this problem can easily be written in exponential form. If we use the same exponential pattern we've always been using, 7 to the power of x equals 115, now all of a sudden we have a super familiar structure, because that 7 to the power of x looks like a 2 to the power of x that we did in the previous problem. The equals 115 looks really similar to the equals 25. I can definitely see some parallels now that can help me say, hey, wait a minute, maybe this is actually the same thing. Maybe I can use the exact same steps. So if I now have the same exact question rewritten, 7 to the power of x equals 115, I'm going to use those same steps. You'll notice it doesn't ask me in question number 8 to do some of the same things that number 7 did, like the estimate what two integers that the answer is going to be in between. But sometimes that is a helpful thought exercise, something to just think about so that you can predict what your answer is going to be. And that does give us a little bit of peace of mind. Like once we get to our answer, it helps us feel like, oh, yeah, that does feel right. And when you're doing new stuff, like this stuff with logs, there's nothing wrong with taking a few extra seconds to giving yourself that security. So I'm just going to do a quick little mental exercise, and I'm going to think about powers of 7. 7 to the power of 1 is 7, that's really small. 7 to the power of 2 is 49, that's still pretty small. 7 to the power of 3 is, and I'll check in a calculator just to be sure, I'm pretty sure it's 343. But let's double check. 7 to the power of 3, yep, 343. Which is clearly too big, so I'm estimating for sure x is going to be between 2 and 3. So that's going to give me a little bit of information going in. I'm expecting to see an answer from my calculator eventually that'll be between 2 and 3. So let's see if we can make that happen. I want to mirror some of the exact same steps that I used from the previous question because I know it worked. And I'm also going to take some time on a bit of scratch paper to write down my steps, so that way I really do have a routine. That way I can recreate the goodness from the first question and feel like this is going to work for every question like this. So the first thing I want to do is to make sure there's a log in this problem. I can't use the power property of logs until I have some logs. The power property doesn't work for any old exponent. Bringing down the x in front of the 7 and calling it x times 7 is not mathematically okay, because that's not true. I mean, 7 to the power of 3 is not the same as 3 times 7. We know that. So we have to have a log in the problem for us to use the power property. And what that means is we need to introduce a log. And when I say introduce, that sounds kind of abstract. Just write a log on both sides of the problem. So introduce or write a log on both sides, which means in action, what that looks like is copying down the problem, but putting log of 7 to the x on the left and log of 115 on the right. So introduce a log just means write a log on both sides. As long as you do it on both sides, that's totally legal algebraically, and that solves the biggest issue that we were facing, which is how do we get that power down? The only way we can bring that power down to the front, make it a multiplication, is to introduce a log. So now that I've done that, step 2 is to use the power property. And again, I want to make sure that my verbiage here is actually helpful. So when I say use the power property, that means bring x down as a multiplication. So on the left-hand side of the problem, I'm going to bring x down to the front as a multiplication. It will say x times log 7, and then equals log 115 on the other side. This is where our algebra kicks in. This is where we say, hey, wait a minute, I can get x by itself. X isn't doing anything complicated now. X is just multiplying something. If I want to get x by itself, I just need to do the opposite of multiply, and that is divide. So at this point, you're not doing any new algebra, but I'll still write some clarifying remarks here as a final step. Get x by itself using regular algebra. In the problems that we've done before, including this one, that means divide. But sometimes there could be other steps. So I'll put divide parenthetically there. That doesn't necessarily always mean you're going to divide. You just kind of have to follow the algebra. Usually it's going to be dividing though. By dividing, you've canceled out the multiplication on the left, which means x is now by itself. On the right hand side, you've got a mess, but remember this is a mess your calculator can handle. So into your calculator, you'll type log 115. And if your calculator has parentheses that open when you press the log button, make sure you close the parentheses before you type the rest of this division. Divided by log 7, close those parentheses as well. It'll give you a decimal. It's almost always going to be a decimal, which we knew because 7 was not really a factor of 115 anyway, so we're expecting this to be a weird answer. And you can usually round it to about 2 or 3 decimal places. I stick with 3 because that's the AP convention. 2.438 looks like our decimal. 2.438 also happens to feel right because I look back at the little scratch work I did. I was expecting a number between 2 and 3, and 2.438 is definitely a number between 2 and 3. You can always check. 7 to the power of 2.438 does get you really, really close to 115. And the more decimals you want to type in other words, if you want to copy the entire decimal that you got from the previous step, 2.438, 412,755, you'll get really, really, really close to what you needed. So it's just worth noting that's not a necessary step, but it can help you feel secure in your answers. And as I mentioned before, any security might be helpful at this point because we're doing something new. Anything to help you feel like, oh, that makes sense, is reassuring. Because when you're dealing with something new, it doesn't all make sense at first. And that's completely okay. This isn't supposed to be easy. This is the first time you're learning that a log even exists, let alone how to use it in any constructive way. So make room, if you can, for some extra little steps like this, and like the checking your answer steps, so that you can give yourself that security going forward. Most of the questions that you'll do on the next page are just practice of these steps. So make sure, especially if you're a written steps kind of person, that you have the steps written down that you can refer to, because we're going to use them repetitively in question number 9. Once we use the steps more repetitively, you may not need to write them and look at them every single time, but having a reference source can really help so that you can build that sense of routine as quickly as possible.